In this video, we will talk about clockwise rotations. We've talked about and we've kind of looked at a clock, and we've seen that the hands on a clock go this way. So if I were to drive a car and turn my steering wheel this way, my car would go to the right. So today we're talking about right turns. Rotating just means to turn, as you know from a few days ago in class. In 8th grade, we're turning figures or points about the origin. And we'll do that 90 degrees, 180 degrees, 270 degrees. We'll also do 360 degrees, but I didn't write that here. If I turn something 360 degrees, that's around an entire circle, which puts me right back where I started, so nothing really changes, which is why I did not write that down here. This is what you guys normally think is tricky. To rotate a figure, we're actually going to turn our page. So we physically rotate the page, and we get a new graph. And you guys are always fine with that. And then we record the new ordered pairs, and you guys are fine with that too. Once we've done those two things, we're going to turn our page back to normal, and then we need to plot the ordered pairs that we recorded. All of that will make more sense after we do an example or several. Rotations preserve congruence, which means that the image is the same shape and size as the pre-image. That means that the side lengths are congruent or the same or equal. This also means, though, that the angle measures are congruent or equal. The angle measures are equal, which sometimes we forget about. Rotations do not preserve orientation, or the shape, or the direction that a figure is facing. And we know that this little minus sign here, that just means opposite, or to change the sign. We're going to underline clockwise, because tomorrow's notes for counterclockwise looks identical to this, just that word is counterclockwise. Clockwise means we're turning to the right in a car. I want us to make a note that turning 90 degrees is one turn. You'll notice 90 times 2 is 180. So turning 180 degrees is 2 turns. 90 times 3 is 270. So 3 turns is 270 degrees. I'm going to grab a sticky note here. So here I've got my normal arrow, and right now it is pointing up. When I turn once to the right, I've turned 90 degrees. And now my arrow is pointing to the right. When I turn twice, now my arrow is pointing down. A third turn points to the left, to the left. That's my hair on the sticky note. And then a fourth turn is right back where we start. We're going to write the rules, and hopefully after this video, or after a lot of practice with rotations, we can kind of understand where the rules are coming from. The rule for a 90-degree rotation is x comma y transforms to the opposite of, that should just say normal y. That should be a normal y. I'm going to rewrite that, normal y, opposite of x. x comma y transforms to a normal y opposite x. You'll notice that the x and the y have kind of swapped places here. A normal ordered pair looks like x comma y, but this one looks like y and then an x value. So here I've got positive x's, positive y's, negative x's, and negative y's on my normal graph. When I turn this once, you can see that now my positive y's are in place of x. In place of x, I have positive y. My negative x's are in place of my normal y's. So a normal y is got a negative x value now. Or an opposite of x, sorry. This would be your opposite y and your opposite x. So because we're actually turning our graph, that's why our axes are actually moving. What started out going up and down is now pointing side to side, which is why we've actually swapped those places there. A 180-degree rotation, x comma y, transforms to opposite x comma opposite y. A 270-degree rotation going clockwise, x comma y, transforms to opposite y, copy down x. So we're going to look at some examples and hopefully understand where that rule comes from, where those rules are coming from. My examples are all using the same triangle, A at negative 2, 1. Negative 2, 1 is A. B at negative 2, 7. Negative 2, 7 is B. I did that so fast. The top line, the edge lines are all 8. So I just did 8 minus 1 is 7. C is at negative 6, 1. So that's C. Okay, so we are actually, this first example says 90 degrees clockwise. And we know that a 90-degree turn is one turn. And clockwise means we're going this way or to the right. So we're going to actually take our paper and we're going to turn it, there's a cord there, we're going to turn it one time to the right. We started here, and I need to turn it one time to the right. And now this is where my triangle is. Now we have moved the triangle, so this, even though my notation is still normal A, normal B, normal C, this is after the transformation, which means this is really A prime, B prime, and C prime. So whereas in the other transformations we had to move something on our graph and then read the points, with rotations we move our graph and then we read the points. So now I'm looking at A prime, and A is at 1, 2. A is now at 1, 2. So A prime is at 1, 2. B is at 1, 2, 3, 4, 5, 6, 7, 1, 2. B prime is at positive 7, 2, because I had to go to the right and up. And now C prime is located at positive 1, because I went right, and then up 1, 2, 3, 4, 5, 6. 1 up 6. So now we can turn our page back to normal. I don't like how it's written sideways, so I'm going to just take a minute and rewrite my ordered pairs. We said A prime was at 1, 2. B prime was at 7, 2. And C prime is at 1, 6. Okay. Now we're going to plot those ordered pairs on our normal graph. We only turn so we can read the ordered pairs. we have our original or pre-image ordered pairs on the graph. We turn the graph, read the image ordered pairs. Now we're back to normal and we can plot those ordered pairs. A prime is at 1, 2. That's A prime. B prime is at 7, 2. And C prime is at 1, 6. So you can see how the triangle is turned. Now this shorter edge, the shorter leg, isn't going side to side, it's going up and down because we've turned this. Now we wrote down earlier that, I'm going to label this as a 90-degree clockwise turn. We know from earlier that the rule is y negative x, and I kind of showed you how that worked on our graph. This is how our graph starts, positive x, positive y, negative x, negative y. And when we turned 90 degrees, positive y's are now replaced, the x is now replaced with a positive y, and the y is replaced now with a negative x, which is why that works. We can see that numerically by looking at the ordered pairs. So I'm taking my x value and I'm putting it where y should be for my new number. And I'm also making it opposite. Let's look at point A for that. The x value in A was negative 2. So I put it in the second position, but I also took its opposite. So instead of negative 2, I was left with a positive 2, because the opposite of negative is positive. Then to get the first number, we're taking our y value and switching it to be in the first spot. The y value in A was 1. I'm just switching that to be in the first spot now. Now let's look at the next example going 180 degrees clockwise. So 180 degrees is 2 turns. Go this way. Sorry. If I turn twice clockwise, that's 1 turn and 2 turns. Now let's look if I go 2 turns the other direction. That's 1 turn and 2 turns. We end up facing the same way. So with 180 degrees, it actually doesn't matter which way I turn, clockwise or counterclockwise, as long as we're doing 2 turns. I've got my triangle plotted, so I'm going to look at this triangle after I turn it twice. The pink one was after I rotated it 90 degrees. So I'm not looking at the pink one anymore, even though it's on my graph. I'm looking at this triangle after I turn it 2 times. So here is 1 turn, and here is 2 turns. And just for some continuity today, I did turn clockwise. Now I'm looking at A prime. This is that point right here. Even though it looks like A, I know it's A prime because this is after I did the rotation. A prime is located at positive 2, negative 1. I know it's a negative 1 because I had to count down to get to A. Now B prime is located at positive 2. I went to the right twice. And then negative 1, 2, 3, 4, 5, 6, 7. Negative 7. And C prime is located at 1, 2, 3, 4, 5, 6. 6 to the right is a positive 6. And then down 1, negative 1. I've got my ordered pairs written down, so I'm going to turn my page back to normal. I don't like how they're written upside down, so I am going to take a second and rewrite my ordered pairs. A was at positive 2, negative 1, A prime, sorry. B prime was located at positive 2, negative 7, and C prime was located at 6, negative 1. Spend a second to erase those. Okay. Now I'm all set to plot my image for a 180-degree turn rotation. So I'm plotting A prime at 2, negative 1, 2, negative 1, is A prime. B prime is 2, negative 7, 2, negative 1, 2, 3, 4, 5, 6, 7. And C prime is located at 6, negative 1. And now we've got that triangle turned upside down. This is a 180-degree rotation. You'll notice that each quadrant here, quadrant means 4, so 360-degree circle broken up into 4 is 90 degrees each. So for every 90-degree rotation, I'm just moving over one quadrant. For a 90-degree clockwise rotation, we went one quadrant to the right, 2 quadrants to the right, or 2 quadrants for the left for 180 degrees. Next, I'm going to be turning 270 degrees. So 1, 2, 3. Hopefully my triangle ends up here. Let's look at the general rule for a 180-degree clockwise turn. The general rule we know because I defined it up here as negative or opposite x, opposite y. And we're going to take a second to kind of justify that to ourselves. Okay. So I say we're going to take the old x value, make it opposite, and that'll be the new x value. The old x value for b was negative 2. I'm saying I'll make it opposite, so positive 2, and then now it should be in the first position. And that was a positive 2 after my highlighter covered it up. So we see the rule working here. Normal x, so negative 2, make it opposite, and that's the new first spot. Make negative 2 opposite, and that's the new first spot too. To get to the new y value, or second spot, we're taking the old y value, so it's 7. We're going to make it opposite, and that'll be the new second spot. The new second spot is just the old y value but opposite. The old y value is 7, so the opposite of 7 is negative 7, which is exactly what we had. And that's harder to see because of the highlighter. Sorry. On our graph, we could see that by rotating twice. Here's my graph, positive y, positive x's, and negative x's. When I turn my graph, not once, but twice, now all of my x values are the opposite x's, and all of my y values are the opposite y's. So going up looks like a negative instead of positive, and going down looks like a positive instead of a negative. Going to the right looks like a negative instead of a positive, and going to the left looks like a positive instead of a negative. Looking now at the next type of rotation, we're going to look at a 270-degree rotation. I just dropped my pen. I'll do this in green. 270 degrees. I'm going to do this in orange because the green is really hard to see. 270 degrees clockwise. 270 degrees means 3 turns. And clockwise means to go this way on a clock or to the right. Okay, so I've got my ordered pairs plotted, and all I have to do now is turn my page 3 turns to the right. So I've got my page turned once, turned twice, and now turned 3 times. And I'm paying attention to this shape. So I'm looking at A prime. I'm going to get another sticky note for this. This pen is not erasable. I'm looking at the new A right here. To get to that A, I'm going left once, which is a -1, and down twice, which is a -2. B prime is located at left 1, 2, 3, 4, 5, 6, 7, so that's a -7, and down 1, 2, -2. C prime is located at -1 and -6. I've got my ordered pairs, so now I'm just going to turn my page back to normal. I really don't like having my numbers sideways, so I'm going to spend a moment and rewrite those. A prime is at -1, -2. B prime is at -7, -2. C prime is -1, -6. Now the general rule, we've got our ordered pairs, so now we should spend some time to plot that on our graph. We're plotting A prime at -1, -2, A prime. B prime will be at -7, -2, B prime. And C prime is at -1, -6. This was a 270 degrees clockwise turn. So now you can kind of see the evolution, turning 90 degrees, a second turn 180, a third turn 270. Now the general rule, or algebraic rule, for a 270 degrees clockwise rotation is opposite y, comma, x. And we'll look at yellow and green. Okay, that is because if I take my graph, here's positive y's, negative y's, positive x's, and negative x's, and I turn this 3 times to the right, clockwise. 1, 2, 3 rotations clockwise. In my x spot, I now have the opposite of y. In my y spot, I now have a normal x. That's why the rule is what it is. We're going to see that it works numerically or algebraically with the numbers as well. Okay, so I'm saying to obtain this first spot, the first spot, you're going to look at the old second spot and make it negative. So the old second spot for C was negative, or was a normal one. I'm saying take that second spot, put it in the first spot, and make it opposite. The opposite of 1 is -1, and that's what's in our first spot. To get the second spot, we're just going to copy down whatever was in the first spot. In our first spot for C, we had -6. In our second spot for C prime, we have -6. We just copied that down. I will work out this problem in apparently black. I thought it was blue because the color of the pen is blue. We want to turn 360 degrees clockwise. That is 4 turns. 4 turns. And again, if I take my graph, where's my arrow? If I take my arrow and I turn it 4 times, if I go 4 to the right, 1, 2, it's pointing down after 2, it's pointing to the left after 3, and it points up after 4. Now let's try going to the left. points left once, down after 2 turns, to the right after 3 turns, and then pointing back up after 4 turns. So it doesn't matter which way we turn our page, as long as the shape will still face the same direction at the end. So, it's me, I'm here. So I'm going to take my paper, and I'm turning it 4 times. And just for continuity, I will go clockwise. That's 1 turn, 2 turns, 3 turns, and 4 turns. Notice my triangle is exactly where I started. So A is the same as A prime. So A prime is -2, 1. B prime is -2, 7. C prime is -6, 1. Since these are the exact same x's and the exact same y's, all in the exact same spots, the general rule is still is just your normal ordered pair x, y. That is all of the notes for the front of this page. I am going to stop the video here. I feel like this page is really great for the explanation and the why behind all of the notes today. On the back of this page, I'm just going to go through several examples, and I'm hoping to go a little quicker, so I will make a second video for clockwise rotations, just a little quick guide. Again, if you have questions or concerns, please don't hesitate to message me on Schoology, send me an email, or drop a comment on the video.